and welcome back to our class of microeconomics. Let's continue with chapter 2 on theory of consumer behavior. Remember last class we have explained about consumer behavior based on the Cardinal Utility Approach, where utility explains our behavior, consumer behavior. Today we'll learn about the second approach, that is the Ordinal Utility Approach. And in this approach, they make use of indifference curve. You'll learn about the meaning and its features, and also the concept of marginal rate of substitution, the law of diminishing marginal rate of substitution. Then you'll learn about the indifference map and the concept of monotonic preferences. Ordinal utility analysis, totally different from last class cardinal utility analysis. Cardinal utility analysis, remember that we assume that utility can be quantified, it can be put in numbers, we can add, we can subtract, then we come to know about our behavior. So by doing so, that explanation, that analysis has suffered major drawbacks. It has its limitation because in real life we don't give number to our satisfaction. So what we do is we can rank different combinations whether they give us more satisfaction or less satisfaction. So when we do so by ranking our level of satisfaction, we'll be able to explain our behavior, and that is what ordinal utility analysis is all about. We have preferences, we have likings on certain commodity, and so based on that, and remember the assumption that we try to study our behavior with respect to two commodities that we consume at a time. Okay, so we have bundle of commodity, either X or Y, mango, banana, or a combination of these two. And so by doing so, with this ordinal utility analysis, we don't give number anymore, but we can rank the different combinations. So if you look at the figure, you'll see that there are different bundles that give the satisfaction, that give the consumer the same satisfaction. A combination, by consuming 15 mangoes and 1 bananas, it gives the same satisfaction as 12 mangoes and 2 bananas. Same satisfaction with point C, where you consume 10 mangoes and 3 bananas, or D, 9 mangoes and 4 bananas. So it depends whether you choose A, B, or C, or D, you'll get the same satisfaction. So you are indifferent whether you consume A, B, C, or D. So the consumer is said to be indifferent on those different bundles A, B, C, and D because any of these points they give equal utility, equal satisfaction. So if you put that, draw that on the graph and join these points A, B, C, D, you get this curve, IC curve. This curve joining all points representing bundles. These are bundles, combination of mangoes and bananas, among which the consumer is indifferent. It gives him the same satisfaction. So it doesn't matter A or B or C or D, it doesn't matter. That curve is called the indifference curve, the IC curve, the indifference curve. So all these points A, B, C, D lying on the curve, not above, not below, they give the consumer the same satisfaction. So that is the main uh, idea behind cardinal utility analysis, of making use of the IC curve to explain our behavior, that we can rank one over the other or they give the same satisfaction. Here you'll get the definition again. An indifference curve joins all point representing bundles which are considered indifferent by the consumer. Okay, but a point to note is that if you want to go from A to B, what you have to do is you by choosing point A, you consume 15 and 1, but to go to point B, even though it gives the same satisfaction, to be able to consume more banana, you have to forego, you have to sacrifice certain mangoes because you have limited resources to get these goods, these commodities. So that's why you have to sacrifice some, consume less of mango to be able to consume more banana. And also from B to C, you have to consume less of mangoes to be able to consume more of bananas. And so from C to D, you have to consume less of mangoes, sacrifice mangoes for the sake of bananas. Okay, so to get one more banana, he has to forego some mangoes. Even though the satisfaction remain the same, the totality remain the same. Okay, but because you are moving on the same indifference curve. So the amount of mango, the tree of mango from 15, now you consume 12 if you go from A to B to get one more banana. So the 3 mangoes that you sacrifice for one banana, not it, to get additional banana, even though satisfaction remain the same, that is called the marginal rate of substitution. You substitute 3 mangoes for one banana. 2 mangoes again from B to C for one more banana. One more mango you forgo, you sacrifice to get one more of bananas. So marginal rate of substitution is simply the rate at which the consumer will substitute bananas for mangoes so that her utility remains constant. So this marginal rate of substitution, mathematically you can find out by this ratio, the change, the delta y is the change in y by change in x. How much you consume of banana by sacrificing mangoes, delta y by delta x. How much you change of y to get more of x. You can also relate that to the table. Same thing like in the graph, in the figure. Here you can see combination A, 1 and 15. Combination B, you want to consume more banana, you have to consume less of mangoes. B to C, you want more banana, you have to consume less of mangoes. C to D, more of it, less of the other. Unless you substitute, you sacrifice, you'll not be able to get more on the other. You have to forgo because you understand your resources are limited. So from the table you can see as we increase the quantity of bananas, quantity of mangoes sacrificed for each additional banana decline. So in this case you can see that way of sacrificing, of getting more of bananas for getting less and less of mangoes, is the marginal rate of substitution. It keeps on declining. You have to forego 3 of mangoes for one banana. If you want more banana, you have to sacrifice 4 or 2 for one banana. Again, 1 for 1. So you can see is that this rate of substitution, that you substitute mangoes for bananas, keeps on declining. That is the fact of getting more of one to get, you have to get less of the other. That is the idea behind the marginal rate of substitution. So you can see from the table that if you want to increase banana, you have to decrease mangoes, you have to sacrifice, you have to forgo. That substitution keeps on declining. That is what we call the law of diminishing marginal rate of substitution. From A to B, you sacrifice 3 for 1. From from B to C, you have to sacrifice 2 for 1. From C to D, you have to buy more to get more banana. You have to sacrifice one more mangoes. That is what we mean by marginal law of diminishing marginal rate of substitution. That MRS, that substitution one over the other, keeps on declining. It becomes a law. Okay, so consumers sacrifice smaller and smaller quantities of mangoes for each additional banana. Okay, that is what we know, what we learn about indifference curve You are indifferent whether one on point A, B, C, or D, but the only thing is that if you move from A to B to C to D, you get more bananas, you sacrifice mangoes, but that way that you sacrifice, that pattern, it clearly see, you can clearly see that it keeps on diminishing, declining. That's why it's the diminishing MRS. That's about the concept of MRS and the diminishing MRS. Okay. Because of this diminishing marginal rate of substitution, that's why it makes the indifference curve to convex to the origin. It's not concave. The shape does not go this way, but it goes this way, indicating that you have to get less of the other to get more of the other part. So that's why, because of that law of diminishing marginal rate of substitution, this curve is convex. It's convex to the origin, because you want to get more, you have to get less of the, in that case, in this case, mangoes. Okay. But there are some cases where the marginal rate of substitution remains constant, even though most cases the MRS is diminishing. But there are some cases where the MRS keeps on declining. The example here in this case is if you were to get more of coins, get more of notes instead of coins, that is 5 rupees. Not it. 5 rupees note or 5 rupee coin, it has the same value. It doesn't matter whether you have more of coins or more of notes. It's the same value. You have, for example, you have 2 notes of 5 rupees, the value is 10. Or you have 2 coins of 5 rupees, the value is same as 10. So it doesn't matter. In that case, it doesn't matter whether you have 1 5 rupee note and 8 5 rupee coins, or if you want to get more of notes, you sacrifice only one because of the same value. If you want to get one more, you have to sacrifice one more. If you want to get one more, you have to sacrifice one more. It's the same thing. That's why 1 is to 1. You substitute 1 coin for 1 note, 1 coin for 1 note, you get the same value. It's not like a commodity where the MRS is diminishing, but we want to see that there are some times when goods are perfect substitute, they serve the same purpose, you are indifferent. That's why the marginal rate of substitution is a straight line, is constant. If you put it in the graph, it will not be convex, but it will be a straight line. Not it. 1 for 8, 2 for 7, 3 for 6, and so on. You'll get a straight line, not a convex. It's convex for most of the goods because of the diminishing MRS, but in this case, it's constant. That's why it's a straight line. Okay, that is only to know about a case of MRS. Okay, this is what we talk about. Not it. It's a straight line. 8 coins, 1 notes. You want to get one more notes. You sacrifice one more coin. You'll get one more note. Same value. Same value. That's why it's a straight line. But this is only for perfect substitute. Then now, so you have indifference curve, which is mostly by nature convex, isn't it? So you can have point A, same satisfaction as point B, same satisfaction as point C, isn't it? On the same curve, on the same curve. But if you have a number of indifference curve in a figure, that is called indifference map. Okay, let's see. The consumer's preferences over all the bundles can be represented by families of indifference curve as shown here. This is called indifference map of the consumer because it has groups of indifference curve. It's like a family of them where it indicates how much you have preference over the goods. It means that if you are in this curve, your capacity is in this curve, then you are satisfied with these combination, but you are in this curve. If you have one of that good, you'll be able to consume more of the other good. It means that you prefer this curve than this curve, because by consuming on this curve, you will be able to consume more of bananas. Consume more of bananas without sacrificing. With the same mangoes, you can consume more bananas. And this indifference curve at this farthest uh, side will will be will be of favorable by consumers, because here, even with the same mangoes, in this first indifference curve, you'll be able to consume only this much of bananas, here only this much, but here you'll be able to consume more. So that's why indifference curve to the right indicating higher level of satisfaction. You would prefer here if it's possible for you. It's not it. But if it's not, then you consume here or here in this curve. So you understand, any point on this curve will give you the same satisfaction. Any point on this curve will give you higher satisfaction than the previous one. And any point on this curve will give you the highest satisfaction than on the other two. But the combination of these indifference curve is the indifference map. Okay, you understand. A number of indifference curves put together is the indifference map. Indifference map, you understand, indicates you the different levels of satisfaction from these bundles of goods. Okay, so that's about indifference map. Let me go back before we continue. What we've learned about the meaning of indifference curve, we understand indifference curve. It's a curve. It shows different combinations of two goods, bananas and mangoes, which gives equal satisfaction to the consumer, no matter where on that curve, no matter on which point on that curve you are indifferent. It gives you same satisfaction. It's not it. And when you talk about the MRS, you understand MRS is a substitution of one good over the other. It's not it. It's the number of units of good Y that the consumer is willing to forego for additional unit of good X. You want more of X, how many you want to sacrifice of Y? You want more of bananas, how many of good mangoes you want to sacrifice? Delta Y by delta X. That is the meaning. And we have also seen that by nature, that MRS is always diminishing. It becomes a law. That's why it gives rise to the convex shape of the indifference curve. Okay, so indifference map, we also learn about indifference map. It's a set of indifference curve drawn according to different levels of utility, different levels of satisfaction. You can have as many as indifference curve in the indifference map. And what is monotonic preference? That is very important in study of indifference curve, is that monotonicity of preferences imply that between any two indifference curve, the bundles of one which lies above are preferred to the bundles which lies below. You would prefer this that lies above than this one that lies below. You prefer this one that lies above than this one that lies below. Okay, that is the monotonic preferences. The proper definition of monotonic preferences here, consumers' preference are monotonic if and only if between any two bundles, the consumer prefers the bundle which has more of at least one of the goods and no less of the other as compared to the other bundle. For example, if you have these bundle, so to say 10 of 10 of bananas and 8 of mangoes, not it. It's not the case of monotonic preference over the bundle 11 and 9, because 10 and 8 has more of both goods. I mean to say 11 and 9 has more of both. Here 10 of mangoes in this bundle and 8 of bananas, whereas here you have more from 10 to 11 and at the same time of bananas from 8 to 9. So it is not monotonic. Monotonic is this one, where earlier you have 10 and 8, but now you can have 11 and 8. More of one, no less of the other, no less, equal. Not it. It's not like in this case, more of one and more of the other. That is not monotonic preference. Here, more of one, same of the other, that's monotonic preference. So that is the point. If you are in a position where you can choose, then you prefer the one that bundle that has more of at least one and no less of the other. Okay, and lastly, let's talk about the characteristic features of indifference curve. Indifference curve has three main features. Number one, indifference curve slopes downward from the left to the right. It's convex from the left to the right. What does it mean by sloping from left to the right, not sloping from right to left or any other shape? It is this shape from left to right. You understand, but because it is so, the consumer has to forego some from here, forego to get more of the other. It has to slope that way. Otherwise, if it doesn't slope this way, if it slope, so to say, it slope like this, not downward from the left to the right, but upward from the left to the right, it means that if you have less of both from one point bundle, if you go to the next point from A to B, you'll have both, more of both. That is not the case. You have to sacrifice to get more. But if it is not that shape, it is like this, then you have more of both. You understand? That is not indifference curve. Indifference curve has to slope downward from the left to the right, so that you have to forego to get more. You can't get more both. Okay, but you understand, any point otherwise, any point you move from one point to other, like earlier, if you want to move to other point downwards, you have to sacrifice to get more, sacrifice to get more. That's why it is sloping downward from the left to the right. Let's read here that indifference curve slopes downward. An increase in the amount of bananas, if you want to increase from 1 to 2 to 3 to 4, along the indifference curve associated with a decrease in the amount of mangoes, not it, from 15 to 12 to 10 to 9. That's the first characteristics features of indifference curve. Number two, as we have learned, in the indifference map, higher indifference curve gives higher level of utility. That means you have many indifference curves, so to say 1, 2, 3, that means the one that is the farthest, IC3 in this case, yields more satisfaction than IC2 than IC1. That is another characteristic of an indifference curve. As long as the marginal utility of the commodity is positive, as long as you get satisfaction from it, everyone prefers more of that commodity, as long as commodity will increase the level of satisfaction. Okay, so that is number two, that the point to the right gives you more satisfaction. In this case, point B will give more than point A because A lies higher than B. B lies higher than A, I mean to say. And if you compare C and B, you would prefer C because C higher than B. Between A and B, you prefer A. I prefer B than A. Between A, B, and C, you prefer A to B or C because it's highest, not it? So the higher indifference curve combination, more mangoes, more bananas, give high level satisfaction. You get more from here. You get 10 and 1, here you get 10 and 2, here you get 10 and 3. So you would prefer C because it gives you more of two goods. That's the second characteristics. Indifference curve, higher indifference curve yields higher satisfaction. And lastly, the third characteristics is that no two indifference curve intersect each other. You can't have indifference curve that cut one another, like in this case here, point A. If it is so, then it will lead to conflicting results. Let's consider first IC1. This is the first indifference curve, IC1. Here you understand, if you move from point A to point B, not it, you'll get the same satisfaction. A or B, same satisfaction, because it lies on the same IC1. No matter what point you choose, you'll get the same satisfaction, A or B or C or D on IC1, and the same indifference curve. If you look at IC2, you will find that A also in the IC2, so you will be indifferent between A and C. This point C here, A or C, because they both lie on the IC2. Okay, so you whether on this point or anywhere A or C or here, you'll get the same satisfaction. So you understand, IC1 A and B same satisfaction, IC2 A and B also same satisfaction. But can it be possible? Because if in that case B is higher than C, not it? In this case, B is higher than C, so you would prefer B over C, isn't it? But then A and B are indifferent. It's the same. And A and C you are indifferent. It's the same difference curve. So you would be indifference between C and B and C. Okay, but that is not possible. A to be on both of the indifference curve is not possible. So point B and C same. It's not it. A and B same, B and C same. A and B same, A and C same, but B and C are not the same. But in that case, it's the same. So it is clearly an absurd result. On point B, the consumer gets greater satisfaction. So he'll be better off point B than at point C. You understand? He'll be preferable here. If you compare between B and C, you would prefer B over C because it's on the higher indifference curve. But how can it be, since A and B is the same, A and C is the same, B and C should be the same. So, but B more preferable than C. So that's why indifference curve should not cut. If it cuts, then it will be conflicting. Okay, so consumer, like we've said, will prefer B over C, even though C is equal to A, B is equal to A. So it is clear that intersecting indifference curve will lead to conflicting results. That should not be the case. So two indifference curve cannot intersect each other. This is not possible. So it should be like this, parallel, so that you would prefer here over the lesser lower indifference curve. So that's about what you've learned. The ordinal utility approach. We haven't able to reach that point. Where is the consumer prefer? Where is the equilibrium? It's not it, but at the moment we learn the concept of ordinal utility approach, where to study consumer behavior, we have to make use of indifference curve. From indifference curve, we learn about the MRS diminishing that leads to the convexity of indifference curve. You learn about indifference map, and you understand about monotonic preference. But we'll continue with this. There are something more, so that we'll be able to conclude that explanation on consumers' behavior. Okay.